Hi class, today we're going to look at parent function for a square root function. So if you take a look at this picture, or this graph, you'll notice that we have a nice little, almost looks like a bird's wing, but that's what happens when you take y equals square root of x. If you go ahead and put in some points, and let me grab my pen up here, let's see, it's not letting me cooperate very well, or it's not cooperating well. All right, so if I wanted to try this out and make an XY table to make the parent graph, what you do is, let's say we put in a 0. Square root of 0 is 0, so we get 0, 0. Let's try putting a 1 in. What is the square root of 1? Well, it's 1, of course, so we have 1. Now, I'm going to skip all the way to a 4, because if I try to take the square root of a 2, it's going to be a decimal. If I try to take the square root of a 3, it's going to be a decimal. So let's try a 4. Because if I take the square root of 4, it's 2, right? So I go ahead and write 2 right here. All right, so that's how you see 0, 0, 1, 1. And then if you actually go out 4, you will go up 2, and you'll see another little point. Okay, and that allows you to make this like, it looks like a bird's wing. That's what the square root function is going to look like. Now that's the parent function. Now we're going to see equations that cause this to move up, down, flip over the x-axis, reflect, just like we have with all of our other graphs. So let's take a look at what that would do. All right. Graph the function y equals 3 square root x and identify its domain and range. Compare the graph with the graph of y equals square root x, the parent function. All right, so you saw what the parent function looks like. Let's see what happens. If you put a 3 out in front for a line, it would cause it to get closer to the y-axis. If you put a 3 out in front of the x in the quadratics, which we just studied, you would also see it get closer to the y-axis. It causes it to stretch. Guess what? No different here. What we do is we can make a table. We can plug in our numbers right in and then plug x in and get a y value, and this is what it looks like. So how do we get our graph? We go ahead and plot those little points. And notice, here's the parent function, the blue line. And look what happened. When we put a 3 out in front of it, it caused it to get closer to the y-axis. Look at the blue line, zip, went up there. And how do you get these points? You simply do like we have been doing. You place the x's in to the original problem to figure out what y is to get the output. All right, let's take a look at another one. So here's that graph again, just making sure you understand. 3 causes it to get closer to the y-axis. All right, what happens if we get negative? What would that do on all of our other ones? Well, if you guessed reflect over the x-axis, you're correct. And then the 0.5, instead of getting closer to the y-axis, that cuts it in half, which is going to cause it to get to the closer to the x-axis. So look what happens here. We can plug in 0, 1, 2, 3, 4 into the x value and use a calculator and get these decimals. And this is the graph that you would form, the red one. Here's the parent function in blue. Here's the red one. Notice what happened. The red line here gets closer to the x-axis than it would have been, and it reflected because the negative sign out in front caused it to flip over the x-axis. All right. All right, look at this one. Y equals square root x plus 2. The plus 2 at the end, when we were working with our quadratics, moved things up or down. It did the same thing when you did a line. It moved things up or down. So it's not going to be any different here. So let's take a look. What happens is when you put that plus 2, instead of starting at 0, 0, it's going to start at 0, 2. So it moves it up. Every single point has to move up 2 points. It's translating up 2 points. Now, in order to get all these there's 5 points, we could go 0, 1, 2, 3, 4, plug them in here, use our little calculators to get decimal values for them, and you would get these points here. We all can do that now. All right. So you have an idea of how the graph is being moved. If you put a number on the end, it causes it to move up or down. If this had been -2, this would have went down 2 spaces. Let's just make sure we understand. Let's go back. Now, when we put a 3 out in front, it caused it to stretch, get closer to the y-axis. And when we put a half out in front, it caused it to get closer to the x-axis, which means it shrunk, right, by a scale factor of a half. And then this one, we caused it to go up 2. All right, so we're getting an idea of how the equation tells the graph where to move. I want you guys to take a look at this question, and it says graph the function identifies domain and range. Now, one of the things I have not been emphasizing, let's go back real quick, the domain and range on here. Domain, it starts at 0 and keeps going to the right, so it's anything above a 0, right? Could it be 0? Yes. So our domain is from 0 to infinity, or x is greater than 0. Our range, notice how for our red line here, if we use this equation, we have y is greater than 2, because the graph for the red is from 2 and above. So it's y is greater than or equal to 2. All right. Let's take a look at what we have here. You guys, I would like you to pause your video, take a piece of graph paper out, and graph this equation. Now, recognize by the negative sign what should it have happen, and the 2 should cause something to happen compared to the parent graph. All right. Stop your video and give it a try. Welcome back. All right, so what should have happened is it should have reflected over the x-axis, and this 2 would cause it to get closer to the y-axis. And our domain, it starts at 0 and keeps going to the right, so x is greater than or equal to 0. Our range, notice it starts at 0 and everything in the graph is below it, so y is less than 0. It is a vertical stretch by a factor of 2, boom, right there. And reflection across the x-axis, boom, right there in the negative sign. All right, let's try another one. Oops, I think I skipped a few here. There we go. 1 second. There we go. All right, pause your video and try this one. Welcome back. This -1 would cause our parent graph to translate down 1, and so that's what it should look like. All right. Pause your video and try this question out. All right, welcome back. We have this translating up 3 spaces, and one thing I did not mention is domain and range. The domain starts from here from 0 and moves that way, so it's x is greater than or equal to 0. Range, look where it's starting. It's starting right here at 3. Oh, right there, see it? From 3 and above. So you have to have y should have been, oh, that's interesting. This is incorrect, the range. Please understand, the range is from y is greater than or equal to 3. And I'll write that down so we make that mistake. Cross that out. Y is greater than or equal to 3. Because look, the graph starts at 3 and everything is above on the y-axis. See all the graphs all above it. All right. Let's take a look at this one. What happens when we put a -4 inside with a root x? All right, let's see what happens to that. Take a guess at what you think should happen, and let's see. From the parent graph, what would happen is you get all these points, right? You plug in your 4, 5, 6, 7, and 8. Why didn't I plug in like a 0 or 1? Because if you plug a 0 or 1 in here, you're going to get a negative number. You cannot take a square root of a negative. There goes my puppy. I guess he likes to be in our videos. So we have y equals square root x minus 4, and look what happened. See what that -4 did? It caused it to move to the right 4 spaces. So it looks a lot like the parent graph, but it moves to the right 4 spaces when you have the -4 underneath the radical. So we would say that has a horizontal translation of 4 units to the right. The domain would start at 4 and go greater than 4. So it would be x is greater than or equal to 4. The range would start at 0 and go above, so y is greater than or equal to 0. All right. Here's another example. Oh, wow, this combines everything. The 2 would cause it to stretch closer to the y-axis. The +4 would cause it to move horizontally. And the -1 would cause it to move down 1. So we have all kinds of things going on there. Here, let's take a look at the graph. Now, of course, you can plug in x's and y's, and this is what happened. So it moved to the left 4 and went down 1. Look at that. Just like our quadratics, the vertex formula. You know how it says, oh, if it's a +4, it's -4? Boom. There you go. There's a relationship here. And the y value is exactly what you say. So that's where the actual starts. And then we go off to the right. And we could just plug in x's and y's into this original equation to get a couple different points here and cause the swoop to occur. So keep in mind that this would cause it to move left 4. This part here would cause it to move down 1. And this 2 would cause it to stretch closer to the y-axis. All right, graph the function y equals x squared x plus 3. Identify its domain and range. Compare the graph with the parent graph. All right, pause your video and give it a try. Welcome back. Let's see how you did. So if I actually put the some numbers in here, and by the way, you can't be negative, right? So we have to start with at least, can't do anything more than a -3. So at -3, we plug it in and we get 0. So there's that point, and then we could do a couple more points, like putting in like a 0, square root of 3. Ew, that's going to be a decimal. What if I put a 1 in? 1 plus 3 is 4. So then I would say, oh, that's a 2. So we go over 1 up 2. So that would be how I would choose my points. Now, the domain. Notice it starts at -3 and goes to the right. The graph is everywhere from -3 to the right. So you have x is greater than or equal to -3. The range. It starts at 0 and moves up. Our graph is anywhere from 0 up on the y-axis. Horizontal translation, 3 units to the left. Plus 3, 3 units left. All right, so you got that. Let's take a look at this. Identify the domain and range of the function in example 5. Well, that would require you to go back, so we're just going to go ahead and skip over that one. All right, so here is your final equation to write down. This is the general format of all square root functions. Remember, this causes the point where we start our square root. This would be opposite h and k was where it's going to start. The a will cause it, if it's bigger than 1, it will cause it to stretch. If it's between 0 and 1, it's going to cause it to shrink and get closer to the x-axis. And this k causes the graph to translate up or down. All right, I will see y'all tomorrow.